Yes. All right. So let me click the got it button. Yeah, cool. All right. Welcome to Back to Basics, subtle bugs in everyday programming. A bit of a light-hearted talk, and it's not terribly technical. So I'm sorry if a lot of you come into here with a wealth of AppSec knowledge and like all sorts of weird little bug classes and things to talk about. We're here to talk about basics, things that you would have learned in either high school or at least computer science 101. Yeah, I know, right? Why is that related to security? Yeah, good question. So firstly, who am I? We know that command, right? So I'm Cole Cornford, not NCSG, but I do contribute to NCSG a fair bit. I was a secure and code nerd at a lot of places in the past. I know Scott and Divya from my time at BestPack. So it was the best, right? Still is? Yeah, Divya? Yeah, okay, cool.
Yeah, still, yeah.
still BestPack. So I also worked at the ATO. Most of the time I was what I'd say a Fortify monkey, where I'd run the Fortify scanner, look what the results are, and then say, hey, let's fix all these problems, right? I have progressed from there and I'm a lot broader skill nowadays. When I was at Change, I did basically all types of security engineering. And so it was governance, risk and compliance, Kubernetes hardening all over the place. And at Lendi, I'm doing a lot of cloud security and DevOps security. So build kite, Kates, OPA gatekeeper, all that kind of rubbish. So I also started my own little business, Galar Cybersecurity, recently. The focus on that is on two aspects. Is either the things I'm really, really technical and good at, which is just broad AppSec things and, so cloud security, security education awareness, public speaking, and AppSec reviews, right? So I do that. I also do broad strategy things. So if you just need a little bit of advice about how do I do this a little bit more secure, hit me up, but not a sales pitch. Let's go. So back to basics. Why are we talking about basics though? Why don't we just cover like really crazy complicated things? Well, you see, it's kind of like, you go back to school and you get taught about computer science, which is like, it's like science, but you don't actually do any science, use computers, right? I don't think I ever had to wear safety glasses, but maybe I'm not old enough yet. So, and you sit there all nonchalant and enjoying yourself, learning about linked lists and having a great time. And afterwards, you sometimes go out and have a few beers with your mates. And at least I think that's all I was supposed to do at university. I just did lots of comp sci, right? I also wrote applications like this. This is like one of my first year programming assignments. Have a read. This is absolutely beautiful code. Like this has got everything you want to go for like a first year computer science student, So I hope you enjoy this piece of creativity. But yeah, I expect a lot of people coming out of university to only be able to just like find solutions to problems, not necessarily to code beautifully like this, right? So it's either my brain is just like university-ish, or it's like these beer pong games I was playing all the time that led to creations like this. But unfortunately, in the real world, I see tons of software that is as high quality as this, and that's okay because that's why we're here, to help fix these problems. We're going to get those burger frogs and King Henrys out of there. So better basics equals better security. And by equals, I don't mean assignment, I mean equality, right? Which is the very common thing to make the mistake, especially if you're using JavaScript, because that uses a triple equals, which is like all sorts of stuff. But anyway, let's start with talking about equality. So who here knows what this does? What is this? What is this thing? It's assignment. We had to do these at university, right? Problem with assignment is that you can use it in all sorts of weird contexts, like this one. This used to be a pretty common kind of pattern that would exist back in the day for C programs. If your C program would crash, it would create an error condition because that would be returned, right? But the problem is it's in an if statement. So this is a relatively primitive way of handling errors. But the big issue of this is that it looks very similar to this, which is a comparison statement. You're checking to see if the error is equivalent to the result of is galah. And those are not the same thing at all, but it comes up. And happens all the time, unfortunately. I'm reading embedded source code that makes this mistake over and over again. So there's plenty of ways to handle this kind of issue. For one is to rewrite it so that you just understand what types of other language constructs exist to help mitigate this problem. You might use throws. You could use a try catch statement, or you could use another method beforehand, even trying to access the variable to see if it's valid in the first place, which is my preferred option because the other ones lead to other problems, right? So just make sure, if possible, don't use assignment in a comparison. So I guess another thing to bring up is that there's also equality. Equality is quite different in different languages. So you need to understand that double equals in some is not quite the same as triple equals. And these operators can be really annoying. So let's go to a bit of a pop quiz about some of them, right? Ready? Ready? Here we go. Gonna ask some questions. So audience interaction needed for this one. You ready? What's this one do? Hands up, come on, let's go. What does this operator do? One of you got to notice. I get to have a sip of whiskey while you think about it. Come on, type in the chat, have some fun. Have a go. What do you think it does? Okay, got no fish biting. Okay, all good. So if you don't know this one, do you know the difference about these two, for example? I see Scott nodding his head.
Yeah, one is binary and one is what do you call it? And operator. So
logical.
Yeah, logical versus operator. Yeah.
Yep.
That's it. Bitwise versus logical.
Same for these two. So the thing is, these operators really do matter quite a lot. The double ampersand, it's not, right? Which is just for JavaScript, basically. It can convert an object in JavaScript into a Boolean, and it deals with falsiness. In JavaScript, there's this concept of falsiness, which is something is kind of false, but not definitely false. So types like null, zero, and undefined are falsy, but they're not false. So what you do is if you double not something, it will convert it into a Boolean by making it true, and then it will convert it into a Boolean false by making it, by notting a true. So that's very important if you're dealing with null types, right? There's also double ampersand and single ampersand. It's great for obfuscating code and creating unintentional pathways. So you need to pay attention to when people are using that, because a bitwise thing means that both sides of the equation get executed. Whereas if it's a logical one, only one side gets executed if the other side is either true or equivalent. So it only needs to do part of the equation to work out whether it needs to execute the rest of it. So this is very important if you have like an or statement, for example, because you could find a way to actually skip logical checks further on if the first part actually occurs. So pay attention to the types of operands that are used in your code. And if you ever see bitwise operands, you need to ask specifically, why does that need to occur? Because there's very few situations where it's necessary. And operator precedence. Did you know that not and increment occur before like multiplication or addition? It makes sense that multiplication and addition, those two are in order because that's what we do in math all the time. But you probably didn't know that if you have a not symbol at the front, that's the first thing that occurs. So this can create some weird logic loops. And I know I'm talking like little constructs, but we'll go into some other stuff later on. So, and yeah, there are a lot of operators out there and they all work in fairly unique ways. So spend a bit of time for whatever programming language that you're interacting with, understanding what each operator does, because there's a good chance that double equals will work very differently to triple equals. And what looks like an operator in one language can be functionally different than in another one. Like I know, for example, I always mention JavaScript because it's the most annoying one, but triple equals compares both type and value, whereas double equals only compares value. And that means that if you have a 0 that's a string, it's equivalent to a 0 that is an integer if you use double equals, which can cause all sorts of problems. So pay attention to these. So implications. You can hide backdoors in your code. Now, I know it seems like, oh, who's going to put backdoors in my code? I'm paying attention to that kind of stuff. But it's not easy. If you have an enormous code base, it's very hard to identify intentional backdoors, right? Sure, you can say, I know every piece of code and I understand what's happening, but over time, you're going to move on to another project. You're going to lose interest in something. It's going to be easy to slip something through the cracks, right? And we see people trying to insert backdoors into code under seemingly legitimate pull requests. So have a bit of a, just keep your spidey senses on if people start to use weird operators, because that could be a good indicator about if they're trying to do something surreptitiously. Similarly, business logic flaws. Your application might not work how you expect it to. If you're using the wrong operator or you don't consider the order of operations, then things will fall apart. And DOS, so big numbers, null, variables, exponentials, doing anything to do with bitwise transformations, or create like situations where your app will crash, which is one of the 3 things of security we care about, making sure that our applications are able to stay available. So, and yeah, bugs. People write some really dumb code. Like I do that all the time. Don't worry about that. I've got examples of dumb code I've written in the past 2 days here. So have fun with those. So my next topic, clarity. Yeah, like beautiful things like this, which is very easy to inspect, friends. Look at this. Oh, I have no idea what's going on there. So, or this, look, it's like some kind of chessboard thing. The bishop W, knight W. What does the number 5 mean? I don't know. I've got no idea. There's no clarity in this code. Or like this. Yeah, collection of words in a hash set of arrays of strings. And I just don't comprehend what's going on here. If you cannot scrutinize the code, then you're not going to be able to assess whether it's got security problems. And there's inscrutable code everywhere. Like every organization I've ever worked at has had code that is like literally indecipherable. So like this, for example, I wrote this Golang 2 days ago, trying to solve an admin of code problem, like challenge, right? And I was just looking through my repository to say, hey, is there anything that looks really crap? Because I was just trying to solve the problem really fast. Yeah, this is terrible code. So if point1.x does not equal point2.x and point1.y does not equal it, then we're going to look for the max between 2 points and the min between 2 points. And then you're doing what is going on. And that's a lot of logic. And it's not particularly readable because of all the y's, x's, and 0.1, 0.2s, right? I'll give you a little bit to pass what's happening here. So fact of the matter is that this code took me, maybe an hour to write all of this to solve the problem. And it will probably take someone about the exact same amount of time to actually comprehend what's going on. And that's a problem in software engineering. It's a lot easier to write code. It's hard to write code that is clear, concise, and readable. And if you're a security assessor, you want a lot more clear, readable, concise code than you do code that is perfect and functional, right? One example where this plays out is regex. I saw this and I was wondering, what does this do? And truth be told, I can't even remember. Like, I'm pretty sure it's for email addresses, but like, I've got no way of deciphering that. Like, what the hell's going on there? Sure, you can throw it into a regex visualizer to try to understand, hey, is this vulnerable to a RDoS type of attack, or like what's going on here? And then you can try throwing a bunch of test cases at it to see how it goes. But the main thing is that you initially cannot comprehend what's going on here. And I saw this one, for example, which is for IP addresses, which I would have thought would be relatively simple, considering it's just either, 0 to 256 enforced places. Occasionally, if you've got IPv6, you could do a different type of regex, but no, they're including octels in here and hexadecimal representations, and also the full IPv6 part at the bottom. Anyone initially looking at this probably isn't going to recognize that it is for IP addresses. And look, it's all right. Regex is complicated and weird, and people don't like it all that much. And most of the people I've met have no idea what they're doing with it. It's completely inscrutable, and it just is magic that just sometimes does what they want it to. Or they do what I usually do, which is they go to Stack Overflow and say, hey, I need regex that does this thing, and presto, this works. So yeah, you pull it from Stack Overflow. I have no idea how it works. Fair enough. So anyway, what I'm getting at is that I prefer regexes like this to regexes like this, even if the second one is technically correct for all postcodes in Australia, even though the first one is a lot more easier to understand, right? So go write regexes that are simple. But I'm not saying go, there's other ways to be clear when you're writing source code as well. Like in this situation, which is absolutely amazing, you have position, 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 entity, position, 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 position equals position. How readable this is, I mean, it's fairly neat, but I don't think someone would immediately be able to grasp that they're going to be able to grab the position of type position from the position, right? It's ludicrous. It's very silly. So, and I've seen that in enterprises all the time with factory worker function getter setter things, right? Or you just have that one line of code that does everything. So, which of course is also inscrutable as well. Or the single method that does literally everything as well. That's a problem too. Code clarity is very important, right? If for anyone, like for engineers writing software, but also for people who are reviewing it too. So you want to make sure that your code is easy to understand, because if you can't understand it, what hope in hell do you have of reviewing it? You also want to make sure that it's easy to change. People don't like changing functions that are complex, that they can't understand what's going on, right? That's why we use like really easy and simple regexes, or that's why we use like cloud configuration files like Terraform, which are YAML based, very easy to comprehend what's going on. And this is why we don't write machine code anymore, right? People are afraid to change things. And lastly, if the code is very clear about what's going on, it's very easy to scrutinize what's happening. But don't go overboard. You don't need to be explicit about literally everything, right? I don't want to see any of this stuff in people's applications, So, sorry, let's turn it off. Yeah, so like direction north, south, east, tons of comments that are completely irrelevant, and like if statements that are dumb. Yeah, you don't need to be that explicit, but there's a difference there. So, all right, next section. Iteration and selection. I thought I'd start with a joke. What is AI? Just a bunch of if statements, right? But So we're going to go talk about iteration first, right? So for, while, do while, all that kind of stuff. So iteration can end up causing performance bottlenecks, but also denial of services pretty quickly, right? So we have two methods here. The left one is for my wife, which is very good. So she's allowed to do that. I'll be able to exit that application one day. So, and the second one is for our, it's a type of attack called a billion laughs attack, right? Where you basically each individual element expands the element prior to it, which will eventually exhaust all memory on a computer if you're able to enter a payload like that. Less of a problem nowadays because we are pretty good with not using XML anymore, but it still shows the issue that iteration can become really problematic if you let it spiral out of control, right? So you don't want to just let your application sit there and just keep consuming user input indefinitely, you know, like it's just running, it's hard. You don't want your application to be running at full tilt all the time. It's just easy for it to break and to crash for no unexpected reason. So, and the other thing is for iteration is that your code and your data structures really matter for how often you're going to be iterating. So take yesterday's Advent of Code challenge, which in a nutshell basically is that you have fish, and those fish, they make new fish every 6 days. I want you to simulate 80 days of these fish to work out how many fish there are going to be after 80 days, right? And it seems relatively simple, like at first, right? Because in this scenario here, you have like an input of 5 fish that are 3 days, 4 days, 3 days, like 1 day and 2 days old, right? And you can see over time, eventually start to get more and more fish as they spawn more and more fish. Yeah, I know. You can see where this is getting problematic. So I was able to solve it, part one, with this very naive solution. But the problem was this was the input, the beginning input for the fish, right? So there's about, I think, 150 fish in there to start with. So considering that, what do you think? Can you guys tell me what you think the problem is with my source code here?
I'm guessing you're going to exhaust memory.
The big problem is, it's basically along those lines. So 150 fish eventually becomes like 300, becomes thousands, becomes millions. Part one was fine because I only needed to iterate 80 times, right? And my computer was able to iterate 80 times pretty well by just continually adding to a list. But the problem is that part two was needed to be iterated 256 times, which just left my computer hanging for like half an hour while I went out to go do the washing or something, right? Came back, still running. So I had to rethink it. And this is something that will occur in everyday life, right? If you don't structure your code correctly and think about the performance impacts, a hacker will be able, with an arbitrary payload, to make sure that your app runs indefinitely and slows down your entire system, if not just crash it. And yeah, all you cloud computing wonks out there saying, hey, don't worry, we have auto scaling. Think about your AWS bills, guys. You don't want to spend billions of dollars because you wrote shit Node.js. Come on, fix that. So here's what I did this time around. Do you see the big difference?
Yeah, so I'm not sure what language you're using here, but before you were appending and making things in a list, and I don't see that happening.
That's right. So this time around, I'm using Golang, right? Because you got to be do resume driven development. That's the cool way forward, right? You just use all the funky new languages. But anyway, the main difference is that instead of using a slice, which is basically an array, and I just kept appending things to this array, I've created a map. The map only contains 8 values, and I'm appending, like I'm increasing the values of the items in the map. So it means that since I'm using a hash map and there's only 8 values, it means each iteration only takes n instead of n by the power of n times, right? And that's why this runs in seconds, but the previous example runs in hours. So go back, have a look at some algorithms sometime and think about whether your code is performant. And it's not just in using the right data structure where this is important too. It's also in your just basic code structure, right? So for A, for B, for C, for D, for E, for F, like will run for a lot longer period of time than if you structure this differently. And if you do things like memoization, which is the idea of if you've already calculated a result previously and stored it somewhere as a memo, you can go refer to that memo to see if you've calculated it before you start the loop again, right? So that's a really good example where that's super important, is when you're doing a Fibonacci sequence, right? So you'll end up with a linear tree because you would have already pre-calculated a lot of the Fibonacci elements ahead of time, right? So yeah, think about how many for loops you got going and whether you've got any, I guess like, yeah, a big O. That's the big one, right? So, and this matters for SQL very heavily. It's why Facebook uses GraphQL, because GraphQL is not going to be doing joins anymore. And with SQL databases, when you have joins upon joins upon joins, you're going to have performance bottlenecks, right? So yeah, your technology choices matter heavily. Moving on to our final topic, selection, which is our favorite. It's if statements, else if statements, else switch, catch, all of those kind of things. So you choose a code branch to go down. And like one of my favorite games in Super Mario World, when you go to the Forest of Illusion, it looks pretty straightforward. You do a couple of levels, you can go straight. But this is kind of like how you'd expect your program to execute. You've already thought about it as the programmer. This is how it's always supposed to execute, right? It's not supposed to look like this, but unfortunately, this is what ends up happening quite a lot, is you think your app is going to work this way, but the way that it actually works is like this, and hackers are able to take advantage of that. So an example would be this code here, which is released on Twitter not too long ago from the Kaseya hack. I'll draw your attention specifically to the very last statement.
It's like some of the firewall rules I've seen.
Yep, just let it through. So the problem with this is unfortunately that it will just let someone get authenticated if none of the other conditions pass, right? And this is in an open source product, so someone was able to find it. Here's another example. So this one's from something Microsoft like runs on their backend a little while ago for their Azure tendencies, right? To be able to forward data to individual containers. So what happens is, firstly, it'll get some data from a HTTP callback, and then based on whether it has an authorization header, it'll either do the top part and then work out authorization, or it'll go to the second part and say that the author's failed, right? The problem with this, though, is that if you submit an empty header, it just like completely skips that top part. So you're left with this, which doesn't seem too bad, except that with this last bit of code here, we have to care about auth failed, right? Auth failed is instantiated to false by default, which is another thing to talk about for another show. So really what ends up happening is just this. If you provide an empty authorization header, it just processes the message. Let's just have fun. Go ahead. You know, who cares about the rest of the code? It doesn't matter. So, and this is in Microsoft's like Azure, like one of the really important parts to actually send data between containers, right? Like you'd think Microsoft would have a handle on these kind of things, and they usually do, but this slipped through. And it's kind of crazy to think about, really, isn't it? That a very simple logic flaw, one that would have been picked up by a little bit of inspection, would have been able to occur like this, right? Who would have thought null authorization header would skip all the authorization checks? This is why I'm a big fan of the concept of front-loading errors. So in your source code, if you have the ability to, at the very beginning of any function, start by looking at all the error states, do that, right? If you're consistent with that throughout your application, it's going to be very hard for an attacker to, you know, get past your authorization and your authentication checks, and then to also submit invalid input, right? And it's a pattern that you can use across all of your functions. So do this. If you do these kind of things as part of the function flow, there's always going to be the chance that you're going to forget about an authentication check, an authorization check, or you're going to let malicious input through. So I always like front loading all of that. So it's center of mind, and it's the first thing I think about every time. And if you did that in this scenario, guess what? This wouldn't have happened, you know? They should have gone through and done the fail state first, not else login okay. So, and look, there are plenty of other basics to cover, but we can do that another time. So in sum, you need to know the operands that you're using for your programs. You should be writing clear code. You need to know about the data structures and about your big O. And don't assume that you know your logic. I'm Cole from Galar Cybersecurity, and if you're secure, you're laughing. Thanks.
Thank you. That was good fun. Any questions or discussions? How about I end the recording and then we can have a chat?